Here in number 5, we're going to have to check and see if this piecewise function is continuous and differentiable. So let's start by checking for continuity. We check to see if a function is continuous by seeing if at 1, those two pieces have the same output. So if I input 1 into the left-hand side, and if I input 1 into the right-hand side, will those two pieces meet up? So let's look. 2 times 1 minus 1. That's my left-hand side. Would that give me the same as 1 to the third? So let's see. This is 2 minus 1, or 1. And this is 1. And so, yes, our function is continuous. So now we're going to check for differentiability. So now we want to know, would the derivative, would the slope of the tangent line on both sides come in at the same value? So what we want to know is, as we approach -1, is the slope of the tangent line going to be the same? And so what we need to do is find the derivative of each part of this graph. And to do that, we're going to have to use the power rule that we learned before. So the derivative of 2x minus 1, well, that's just a line with a slope of 2. And so its derivative is, of course, always going to be 2 for x less than 1. And then in my second piece, I've got x to the third. So that derivative would be 3x squared for x greater than or equal to 1. So the question is, at x equals 1, are the values of f prime of x the same? Well, we know from the left it's going to have to equal 2. So let's check what it would be from the right. So we've got 3x squared at x equals 1. And so we're going to do 3 times 1 squared. And we would get 3. So that tells me the slope from the left is 2. And the slope from the right is approaching 3. Whoops, can't spell from the right. And so we would say this function is not differentiable. It is continuous, but not differentiable.